Okay, what today we're gonna do is make a binary clock out of an Arduino board and 13 LEDs. You can use switches to make the time adjustment, but I'm not going to because the budget didn't fit it. So we're gonna make end up because I had to get a case and I really want to get a case for it. And the case cost me like $3, and and I just didn't have enough money to get the buttons or the everything I wanted. And besides, I can always program it to the computer with my script I made that automatically set the time on it from the computer. Of course, you gotta have the Arduino software on it, the compiler, IDE, whatever you want to call it, on the computer. I probably recommend having Windows on it. Linux, you'll have some issues with it automatically. You can do it with Linux. Thing is, you won't be able to automatically upload the sketch to it when it's done to it. You'd have to do it yourself. That means you'd have to go in there, open up the file, and do it yourself instead of the program doing it for you. So when you go to the link below, you'll see there's a page there, and you can just click the download button. It'll download a executable, Windows executable, and then you can go into command line and type in the commands that specify how you want to configure your binary clock. So let's get going on that. Okay, from the command prompt, we're going to type in, we'll give it no parameters to see what we can do with it. And it comes up with a whole list of stuff. You can even use UTC time if you prefer that for your binary clock by passing a /UTC into it. If you want to change the time zone, /bias is what you use. And the offset's in a time format. That means you type in, it's like a regular time, like, for example, mine would be for 6 hours, it would be 06:00:00, not O's. /midnight means that if you don't want to have it set like a computer, but you want it automatically start at midnight every time it turns back on, that's what there, just in case if you do add buttons, that might be a good feature to have, so that it doesn't automatically start at some weird looking time when it reboots. /C shows you the circuit. We'll go over that in a minute. That's for the file name. And the file name should not have the .ino extension in it, and it should be a file without an extension, because it's going to save that into a folder named with whatever file name you put there. Then it puts a folder for a file in that folder, and it names it with a .ino file when it saves it. /up means it's going to upload the script, the sketch to it automatically after it gets done making it. /UTC means it's going to upload, means it's going to be in UTC time instead of the local time. /24-hour will be making it 24-hour format. /12 means it's gonna be in 12-hour format. /LED specifies which logic level will the LED be on, will LED be turned on at. Because anyway, LEDs can only flow through an LED only one way, and sometimes people don't want to have a common cathode, which means the common is ground. Some people want to use common anode, which the common is positive. So if we want to use common anode, you put what a number is, a 1. And then most of these options are optional. But remember, with the time zone one, you should always put /UTC in it so don't confuse the script maker and making it using your local time. /HBTN, that tells it the hour button. Analog pin for the hour button. Why it has to be analog pin is because all digital inputs are already used up on it. So that means you're going to have to use the analog pin. /MBTN, minute button. Then for the /NBTN, there's an option I'm going to use since there's going to be no buttons in it. That will disable all buttons on it. So that means there'll be no buttons on it whatsoever. Then there's an example down there that shows you how to use it for LED for low value and all LEDs and UTC time and 24-hour format, and it puts it in a folder called My Bing Clock. Get this out of the way. And just stores it there. So let's take a look at the circuit, shall we? To do that, you can do that by going to the web page, which will show you the circuit. Or what we could do is in your download, is open up the program for /C option, just like I said. And there it is. Over here is your buttons that adjust the time, once per minute, once per hour. Then R1 goes to pin 1 of the Arduino, R2 goes to pin 2 of the Arduino, R3 goes to pin 3 of the Arduino, so on up to like 13 over here. 14 is where it goes to, 14 and 15 are just your pull-up resistor for you know what I forgot to put in here? I forgot to put the equation for the resistors. So you probably wouldn't know what these resistors values are. Well, all LEDs have a current limiting value for it. I use 1K. You can probably use 1K for it. It's probably best to use that because Arduino pins don't have that much current. Not much made to handle much current. And 1K will like the LED that when it be like too darn high to make it where it wouldn't light the LED up. So yeah. And then right here is the default. It says right here, these are the analog pins where they go to. But the thing is, these tell you what the default ones are. If you change them in the command line, you define them there, they'll be different. So make sure you look out for that. And then make sure that your R14 or R15 are 2.2K instead of 1K like I'm using for the LEDs. Use 1K for LEDs, use 2.2K for the port resistor for the buttons. Okay, now we want to upload. I'm going to upload it to the script here, to the Arduino I mean. In order to do that, we'll type in that /, we're going to use 12-hour format. You want to upload it, so put /up as the next parameter. These don't matter which way you put them in there. You can put them any order you want. Because the thing is, my program checks to see if it can find it in the command line at all. And that's how it works. I'm going to make backslash. Make sure you put no buttons in it. Like that. And if you leave out backslash f, that means we're going to have it as bingclocks backslash bingclock.ino. Where the first little thing before the backslash I'd put in there, but I said it's going to be the folder for it. Since Arduino has folders for the programs, then it must have a separate folder. You can't store all your source code, your sketches in one folder. You have to have separate folders for them. So that's why it does it like that. And that's why you have to leave out the file extension on the file name when you specify it in the command. Okay, let's tell it to go. I think that's about it. Okay, now it's any minute now. The LEDs on that thing that should start doing it. Because you can see on the computer, I just open up Arduino. Any second now, so it's going to compile it and upload it to there. That was probably it, right? Yep, there it is. Let's take a look at the time, shall we? 12:56, and the first LED is one's column of the minutes. And it looks like it does have a 6 on it. Second one. Yeah, there's supposed to be 3 of them there. No, 4 of them. $12.56. 56. Four plus 2. There's a 7 there. Then the next one number is the 5. Yeah, that's correct. Never mind, I was thinking wrong. Because 7 there, because now it's 12:57. The 8's a 0. 1's a 1. 2 is 0. 4 is 1, because 4 plus 1 is 5. 4 to 5 and 50. And there you go. It works. Now you probably want to see the code of it. Well, let's take a look at that, shall we? We'll bring it up in Notepad. See, here's what this code is originally from Daniel Spy something. It's Andrea. He has a website. Anyway, I made some modification to it. This is okay because this is open source. That means anyone can modify it. You can get the source code to it. It's just like Linux. Anyway, right here I have put these weren't there before, these defines here, because it didn't have the capability of doing 12-hour format, and I wanted to do that. I wanted to be able to read 24-hour, 12-hour format. Before it could only do like 24-hour. And What else is there? I put, you can see here all of the off. That's all of the on and all of the off right here. Those are what I automatically got configured for the levels of it going to be when it's on or off. Our format is defined as 12 for 12 hour. Now these are don't have to define right by them. And why is that? Is because we want to be able to change it. So we made a byte out of it. It's because basically a byte, it can have a number between 0 and 255, which an hour can have like 24 hours or up to 12 for 12-hour format. And minutes and seconds can have up to 60. So it don't never ever go over a byte. And that's what they did is they used integer, which is like a 4-byte number, which goes greater than that, way bigger than that. So I left some of the stuff I left alone, like the right here. I could have probably changed this to byte, but I decided not to. Just decided to do the first hour, minute, and second declaration as a byte. It'll help save space on the code, so you can, if you do want to adjust it, you can adjust it better. You don't have to worry. It would very much less likely to have it to go over the space on the chip that's in the Arduino. Then you define button is enabled and set to false. That tells it there are no buttons enabled. Because if you go down, I'll show you. Down here, where there's analog read one, it says if buttons enabled, which should always be false. And it will never execute this code in between the squiggly brackets. Oh yeah, and also you could also uses the. I never had a problem with this, so I don't think I could have probably put that in there. But that's okay. It actually had a problem with it. I'm not going to worry about it. The LED turn off thing. To turn LED off, you have to put a 0, a 1 on. Is it 1 or a 0? I think it's a 0. It's a 0 on it. So it must be since it's floating, it's a 1. Which don't matter. And if it has a big problem with it, you just take one wire, put it to a high, 5 volts or so, pin on there. Because the thing is, with our minute buttons, and with that there, if you had to, you notice it was causing a problem, which didn't cause it for me. Only ones that caused problems was the hour and minute buttons being enabled with them not there. So what I did is once I set them to the high, put them to 5 volts, it made them where they stop going too fast. And that's basically what it does. And this code is basically, there's a site here. You may want to take a look at that site there. I might try contacting them if I figure out and find a way and tell them about this. It's probably not a big deal because it's just open source code. Because like I said, open source means you have the capability of modifying it or distributing it. And I'm making sure to give them credit and not taking this credit out. I'm leaving it there, and I'm also putting in there that I modified some of it so people know about that. And The only thing I modified on it was give it the capability of 12-hour format and the pin configuration, have custom pin configuration just in case if people don't like the way that he did it with the LED pins and the hour and button pins, then they can change it more easily with the compiler I made, the generator I made, the executable generator that you download to make the sketch. And when I see / insert point, that's where all the variables get inserted, right where that comment is. So that's where it tells my program to insert it at. Well, that's about it. I hope you enjoyed this video. Thanks for watching. Hope you like it.